morning, everyone. For those who have problem with my name, I always explain to people, it's actually, if you're English speaking, it's very, very easy. In English, when you say you don't want any more food, you say no more. So you just say it backwards, and you get my name right. So that's the trick. So thank you for joining us today. It's a pleasure to have you, and we hope you have a fantastic day with us and you come out with new ideas that you can take back in your business, and that we will be able to continue as a conversation throughout the year. But before I start, about a year ago, and we've already forgotten, the Houston area was in a little bit of a mess, so this event would not have been possible at all under the conditions we were in at the time. And unfortunately, there are other people in the U.S. today and in other countries of the world who are exactly in that very same situation. And in the news in general, people are talking more about resilience, because people have to overcome such catastrophic incidents. And here in Houston, if you walk around, you see, just 1 year later, you see no traces of this at all, very much, but in people's life, there are lots of traces. And if you go into some of the most affected areas, you will still see signs of what happened. But as we know, life must go on, and we must find a way just to remember. So here in Houston, we had a bourbon distillery which was impacted by the Harveys. So what they did, they salvaged a few barrels, and out of these barrels came out 2,000 bottles of a release, which is probably not the best release, because they were only in barrels for 2 years, but they were salvaged. But they called it Harvey's Remnants. Okay, so it's limited availability, but if you are resilient enough to stay with us until the end of the day, we will have a bottle for one of you to take home. So let's go on to our topic. Today, my goal, my mission is to introduce the day by giving you the background of digital transformation and why we think we play a role in this domain as PIMSoft. And I will do this by kind of going back a little bit about the transition from big data to digital transformation. Then take a look at what is it we call digital transformation. It's a very popular topic, but perhaps all of us have a little bit of a different definition of what it is. And what's the relationship to what we do at PIMSoft and with Sigmafine to digital transformation, which is also another very interesting question, which we hope will be the major development we will do today. Big data. The big data thing was very hot topic not so long ago. It's a little bit less now, but it's still something everybody remembers. And it happened all of a sudden. It caught everybody by surprise, because big data was not something that was intentional. It's not something that was happening by design. Big data happened as a consequence. It happened as a consequence of all the technological development that took place from, let's say, mid-90s to the first decade of the century, year 2000, and so on, because we were building things we're innovating in a very wild way, I would say. Everybody was developing new things, and a lot of devices and gadgets have come and gone, and new ones have come, and some have stayed, and some have become giants in the industries. But all of that was actually generating tons and tons of data. Many people would even call it, use catastrophic weather analogies to describe big data, like a tsunami of data or eruption of data, and so on and so forth, because it wasn't something that we controlled. It was informative, but it wasn't something that we controlled. Digital transformation, on the other hand, is not something that can happen as a consequence. It has to be something that is done in an intentional way, because digital transformation is about explaining. So as much as big data was informative, we could say that digital transformation is more explanative in the sense of what it brings to us. And it's really helping us. The goal is to understand the relationship between that data and the effect it has on what we're trying to do in the business in general, in the process industries at least. So that's how we see it as this, at this point in our kind of history of information, that we are coming to the rise of the interesting period that is following the big data event, which we could describe as something that everybody saw coming, but nobody was really controlling. Then digital transformation. One thing I was really surprised when we were preparing for this event is that how many events are talking about digital transformation. You know, when we were sitting back and thinking about this, we thought we were going to be unique. In fact, we're not. If you look ABB, Emerson, you go through the whole industry, and I'm sure if you talk to any other vendor, everybody has digital transformation somewhere in a sentence, okay? And this is pretty much evidenced by how many searches are done for digital transformation. It's a very large amount. It's really a very big topic. And in our industry, it's a super big topic relative to the entire space of everybody who's doing digital transformation, because we are an industry that has very high dependency on the information. We cannot see what's in a tank. We cannot see what's in a pipe. We have to rely on sensors or device or things or ways to infer what's going on inside the equipment. So in that sense, we are very much a information-driven business, and we are very much interested by digital transformation, as evidenced here by the interest of people. So this is a very interesting development for our industry. So how did we get here? I mentioned big data, but in fact, it started a lot earlier than that. Those who are of a certain generation remember when we were installing converters from 3 to 15 PSI to some kind of digital or numeric output, and then the distributed control system came, and then everything. So we went through that phase, which was really a lot of investment and a lot of hard work. And I was talking even with David this morning. We were talking about all the things we had to do back in those days to just convert things into other things, because there was no technology available. You had to innovate every time. But this was the beginning of people, and especially in the process industries, trying to understand, trying to get to the information in a way other than with a pen or a log sheet or a pencil or a piece of paper, trying to get there. And this was a tough ride, and there were a lot of failures but a lot of successes. So at that time, a piece of data was everything. Then we came into distributed control system and having computer systems that were able to pull this together, and everything was about a database. And we have some OSI soft people here in the room. This was the golden era of the PI system, for example. Everybody needed a place to put that information, and this was more the digitalization phase of where we were at that time, where the idea was just to collect that and organize this. Okay, the focus was organizing it, structuring it, collecting it, being able to get to it when you needed it, and this was really more about a process that we were doing at that time. Today, with digital transformation, in many ways, it's an opportunity to disrupt. The strategy is completely different. Let's go back to where we are today. Today, with digital transformation, it's about disruption. Okay, it's not about technical things. It's about pulling together everything we have, which is business imperatives, technology, knowledge about certain process, pulling it all together and changing the ways we do things. So digital transformation is really how do we do things in a digital way? How do we do the old things we were doing in a new way? And this is not something that is, happen, like I said, happening by itself. It has to happen by design, and there are steps to follow into this process. So right now, what matters the most, if I can summarize it, is the data set. The idea of a database is understood. It's a commodity. Okay. Now, what matters is what is the data set you can pull together in order to do what you want to do from a business standpoint. So we've gone from data to database, and now to the data set, which is fit for what we want to do. To me, that's an interesting evolution for where we are. Then this idea was actually, it's becoming really mainstream, because at the country level and at transnational trade or organizations, people are putting together, big strategies, which I call advanced manufacturing strategies of all kinds. But they're all based on this fundamental concept of the fact that you can represent your assets, your operation with information. So you can do a digital transform, if I can say it this way, of what's happening in the plant, and then you can start the process of digital transformation. So you've heard all about Industry 4.0. You go to China, it's Made in China 2025. We have friends from India here where they have Make in India, which is another spin. We have in the US our Smart Manufacturing Leadership Coalition, which I don't know how strong it is, but for a while it was trying to get somewhere. They have the same thing in France. So all over, every country in the world, if you Google their Department of Commerce or Department of Industry, they will have a study just recently done in Australia, in Brazil, everywhere. Everybody is into Industry 4.0. Everybody is into this thing as a way to transform this, I would say even the society in these countries, transform the way that people are living, okay, by introducing digital transformation through these strategies. So it's not really a small movement. It's a very significant movement. But at the base of that movement is what a lot of people are referred to as the fourth industrial revolution. So this is where digital transformation kind of, takes a new meaning. We are now dealing with cyber-physical systems, and this is the driving force for a lot of investment, driving force of how companies work together to review business process and everything. And the result of that is something that, again, we're coming back. We're generating, in order to enable these strategies, we have to create what we call at PIMSOFT like an industrial plant data set. We have to have a representation of everything that is going on in the plant, that is digital, that we can work with, that we can trust, that is suitable for the purpose that we want to have. Okay, and this kind of data set also has to be designed for a pretty wide audience. I mean, there are people who will want to consume this data. There are business processes, which is probably this class of user is probably the one that is the most creates the most value inside the organization, because then we're talking a bit about automation. And then our other applications have dependencies on this data set to perform whatever they are performing. So the industrial plant data set is a very important concept, we think, going forward. And as we try to pull it together, then we realize it may not be so perfect. Okay, hence the idea that you have to work on it a little bit. And this is where the idea for us come of conditioning the information in order to make it usable in these strategies. Okay, because a lot of companies, I've heard, have tried initiatives and failed because the initial quality of the information they were working with was not there. They just were spending more time trying to fix the data than they were trying to innovate. So some people are taking a step back, and they're coming back to this fundamental that if you're going to do something, and I think Massimo will give you a few examples, if you're going to get into this digital transformation business, the starting point, your industrial plant data set, has to be properly conditioned. And conditioning, is something, it's all around us, okay? The air here in the room is conditioned, okay? Why? Because we want it to be comfortable, okay? People spend a lot of money with creams to condition their skin because they want to look great. Okay, so conditioning always has a purpose. You don't condition without a purpose. And it's the same thing with Sigmafine. Okay, Sigmafine, in fact, is the way that you prepare your data for a given business purpose. Okay, so that's why we're coming with this concept that Sigmafine, okay, it does data reconciliation, it does data validation, it does a bunch of things like this, but these things are methods. They're let's say, low-level things that we have to do to achieve the proper conditioning of the information. So that's our message here for today, is how we use Sigmafine to take the data that is being produced and assembled into a data set and make it suitable for the purpose that people have, which is associated with their digital transformation initiative. That's our story. And if you want to read a little bit more about that, there's a lot of books, but there's some milestone books that have come out which are quite interesting. For example, Alvin Toffler, it's a very old book, but it still was predicting a lot of what's happening today in his own way. Then this book about Vaporize, okay, is quite an interesting read as well, because it takes you through all that wild, let's say, race for innovation, where things appear and disappear, and things that are tools now become abstracted in an iPhone or all kinds of things. So the world is changing very fast. Infonomics, the new science of what's the value of information. Okay, this is fairly new, not really recognized by CPAs around the world yet, but it's emerging as how do we value the information of our business? Because now we have to understand that the representation of our business asset is digital. So somehow it has a value. If I'm selling you a car and you don't know the history, and I'm selling you a car and you know the entire history, which one do you think is most valuable? Or which one do you think will be a better deal to buy? Okay, the one with the history. So it's the same thing. This digital transformation is creating a potential for turning data into value. And then the second machine age, which I think a lot of you have read or have heard about the Industrial Revolution. So at this point, I would like to pass on to Massimo. He will continue by giving you some tangible examples of what we're talking about.
So I'm going to shape this concept of conditioning data for digital transformation into the Sigmafine environment. But let me start with a segment of an old movie.
It just might be a feedwater smell. Can't really tell. You're going to need that feedwater later. Than how they're doing my hand. Do it. Hold the isolation valve. Will everybody please go back to their stations? We're trying to handle the goddamn thing. Jack. What? This one on the indicator. One of them was low. High.
Okay. So this was from the China Syndrome, 1979. It was a clear example of a bad decision based on bad data. So in this case, we had the shift supervisor, who was interpreted by Jack Lemmon, was believing that reactor water level was high and they took a decision based on that reading, but instead it was low, and they had no system of check and balances to discover this discrepancy. Okay, obviously this was from 1979, so 40 years ago. Now we have smart sensor, we have even analytics on the edge, okay? But still, again, the magnitude of the data we have to process and the depth of the analytics we want to run on such data is challenging us, and we have to face many other kind of disruption and problem of the data. So even if this can sound, let's say, kind of old, the problem is still there. So there is still a need for data conditioning. So what I would like to do, I would like to go through a real example of what does it mean conditioning the data in the digital era. So here we have an example of an application built to monitor the performance of a refinery furnace. And typically we are acquiring some process data through our real-time digital infrastructure. Some of this data is furtherly transformed with some calculation or some analytics. And then we build our nice KPIs. In this case, in this real case, the KPIs were related about the furnace efficiency and the percentage of oxygen in the flue gases. Okay, so we are happy with that, but you know what, if we analyze this, when the customer analyzed this, they discover that these two indicators were actually not correlated. So the correlation supposed to be didn't appear. And why this? Because even if the meter were good, there were not bad meter, all the transformation were good, still this dataset contained an amount of error that affected the elaboration of the correlation. Therefore, in these cases, this dataset was not usable. So what happened in this case, we used Sigmafine to clean up condition the data, and suddenly, after this passage, the correlation appears, which is the real one expected by the process engineer. So the higher the efficiency, the lower the percentage of oxygen in the gases, and vice versa. And now, yes, we build our conditioned data set, and now, yes, we can build our KPIs. Okay? So the KPIs coming out from this conditioning are much more robust and accurate than the previous one. Okay, is this something new? Okay, no, because we have been introducing this concept of data conditioning, but data conditioning is there. So those are examples of application we have been doing, and most of you are using in your companies, which are based on this concept of data conditioning. So we have production accounting, reconciliation, inventory managing, and so on. Now the point is that what the market is demanding, okay, pushed by this digital transformation era. And instead of telling you what we could be doing with Sigmafine, we would like to explain to you which are the challenges we are called to face by our customer. And so what I would like to do, I would like to give you some example. So we have, first of all, some challenges which are coming from the operational technology side. And those are real examples. So here we have an upstream company which is requesting Sigmafine to be configured in order to validate the well production flow meters every 10 minutes, not just because they need this for accounting, but because they need conditioned data to take nearly real-time decision in their operations. Another example is a customer in the midstream market. This customer is selling gas storage services. So they have caves, so they don't own the gas, they sell the services. But still, in order to be able both to monitor and to bill for such services, they need to reconcile these gas inlet outflows every 5 minutes. Another example, more in the classic world, in a refinery, we have a refinery where, yes, they are already doing the daily mass balance, but at the same time, they would like to reconcile every hour their process units because they want to compare the scheduled refinery yields with the actual reconciled refinery yields in order to drive better operation decision. In other terms, they want to understand if the vector of the scheduled yields is approached the right way by the operation, or if there is a significant deviation, and then they want to discover this at the end of the day. So this is a kind of usage of Sigmafine to support, again, operation. And finally, we have another example where Sigmafine is used to optimize the logistic operation. In this case, Sigmafine is called to estimate the product properties in nearly real time, and in order to have a better estimation and avoid the demurrage cost, avoid off-spec product. So those are kind of OT challenges. What you can see is that they are coming from different industries, and there is a constant in this. So the fact that Sigmafine is called to be used in a time frame which is not the classic time frame we are used to think about. So we see that there are customers talking about hourly basis, even customer in nearly real time, 10 minutes, 5 minutes. On the other side, there is another demand. This is coming from the IT side of the digital transformation era. So from the IT guys, many companies are even creating position to drive the digital transformation of their company. So we know there are head of digital transformation, head of innovation, and those guys are building up this big digital real-time infrastructure. Typically, they use their some cloud technology. Some of them, they built up big data center and private cloud. But then these IT people is called to face a challenge because on the OT side, they are requesting, yes, I do want to implement this application, but how can feed this application with good data? Okay. And a very clear example is this one coming from a pharma company, which is starting to apply Sigmafine. In this case, they invested the money to implement a predictive analytic tools to predict the batch quality and duration based on process condition. And this is based on the machine learning technology. So in this case, the problem is that they were finding a hard time because both the training of the model and the running on the model are obviously affected by bad data. So biased data, biased model, biased prediction. So this is another case where we have been founding Sigmafine call to action in an industry completely different from the classic industry where Sigmafine has been implemented. And finally, we have seen another reason for digital transformation. For example, many companies, they are going through some dynamic business model, and they would like to serve a new operation site, a new facility, with a set of applications they have been consolidating somewhere in their cloud. So we have seen that Sigmafine is one of these applications, and we are called to be able to support this strategy of deployment, easy deployment to new operation site, to new facility, to new businesses. So Sigmafine is called to be scalable and is called to be also remotely accessible. So basically, this is leading to what we feel is a good definition for Sigmafine. So Sigmafine in these digital areas to be seen as the data quality provider for the real-time digital infrastructure. So a key point is that Sigmafine is model-driven. So we are stressing a little bit this concept because nowadays everybody is talking about data-driven analytics and so on. But let's say we believe that a model-driven analytics like Sigmafine can embed your process knowledge, can embed your business rule in a clearly explicit model. And this serves to build the conditioned data set that can be then consumed by data-driven application. So this is another role where Sigmafine can play as a cornerstone in the digital transformation. And basically, what is needed on the Sigmafine side to be able to sustain this new demand? So this is how we see the Sigmafine digital transformation. So Sigmafine needs to be digitalized, and some of these concepts are already available and implemented. So first of all, okay, we have to be a configurable, flexible system of check and balances, which is already there. But then we have also to support, we have to shift from single context to multiple contexts. So a single context could be like a classic production accounting daily in a refinery. A multiple context can add to this basic context new models, new analysis, energy balancing, production, quality tracking, and so on in the same system. This is already feasible. Also, we have been seeing that the time frame on analysis is shortening. So we are called to configure Sigmafine for hourly analysis, or even in near real time on moving windows. And this obviously brings the need to be able to operate Sigmafine unattended. Obviously, we cannot think to solve the problem of a large site-wide production accounting in an automatic way. This is not the case. But if we are talking about performance monitor based on reconcile dataset, yes, this can be done. And therefore, Sigmafine has to be able to be automated and to be scheduled for that. This means also that we have to be able to bring data and validated data automatically. Okay? And another way to describe this is about the user perspective. So another requirement that we've been facing about customers that they would like their, let's say, balance to be produced in a collaborative environment. So there is not only one person, okay, in charge to solve the balance. There may be more people, 5, 10, maybe one for each area, each one solving their part of the problem, but still consistently solving the full problem together. This requires some shift in the technology in order to be able to support this scenario. And again, if you want to be able to support a big corporation in adopting Sigmafine as a standard tool for a wider set of applications, we have to be able to scale up to a company-wide adoption of Sigmafine, and this also is passing through the need of moving from a client-server technology to something defining Sigmafine more like a web app, so a more accessible data quality service throughout the company. Okay. Before to finish, I would like to show that what we are talking about, it's already real. Okay, so what we are going to show now is the furnace performance monitoring application live. Can you? Are you showing this? Okay, so I'm done. So what you're seeing here, this is a Power BI front end. Behind we have Sigmafine. And here we are seeing the example I showed before of the refinery furnace. So on the left side, we have the unconditioning dataset. On the right side, we have the conditioned dataset after Sigmafine processing. We have about 3 months of data, and each small circle represents 1 hour of data. So each circle is a 1 hour case in Sigmafine language. And all the core are representing the different production batches. Okay, so this is live. The customer can see this through the web interface. They don't even perceive that behind there is a Sigmafine engine to condition the data. If you can select a couple of batches. So, okay, so this is a tool where you can even select the batches and also compare the different performance of the batch. In this case, the batches are referred to crude batches. So we are processing different types of crude. Okay, so we are not talking about a far future. Some of the things I've been showing are already there, okay? And okay, so what is behind this application? There is a stack of technology. So first of all, the PI system, which is the real-time data infrastructure for this customer. And then there is an automated Sigmafine model, which is empowered by thermodynamic calculation and is performing a mass energy balance. And then there is an automated publishing through the BI layer, which in this case is done by Power BI, but it could be whatever kind of technology.